Sir,
Ah.
sir, in the previous question, at that instant it will rotate about C and then about P, right? So then pure rotation.
At that instant, center of mass will descend vertically down and the square plate will rotate about C so that the string will be taut and extensible. After some time, it will swing about P.
Yes, sir.
And that's the condition. Yeah. Okay, read the question and get into the diagram. Initially, will there be any springs? What is the state of spring? Elongated or compressed? Check that. The spring is cut, so it will be like this. Huh? No, initially, what is the state of springs? Will be elongated. We know it, so it will be kx naught. I'll just show it. Kx naught and the weight mg will act. So for equilibrium, what we can write it here only, I'll write it 2 kx naught minus mg equal to 0. Now get into the, now what will happen to the weight mg should act. So the weight mg will act. I'll take it O, this one, because C is given, no? I'll make it O. Then spring is there, no? So let's see, any changes will come to the system. Everywhere, what happened, where all string is there, try to bring spring and analyze the problem. And I think everyone, we have put enough effort on the springs. So we know enough ideas of spring. And we can manage very comfortably with the spring force also. What happened to spring force? What happened to spring force in the spring A? Should change or should not change? What happened the tension in the left string after cutting the right string with chain? No. So here, sudden change in spring force, possible, not possible. So the spring force will remain as it is. Sudden change in spring force, not possible. So spring force will remain as it is here. Then what about the torque? So it will rotate about center of mass, alpha O, and it will have AO. So let me write the corresponding equations. Kx naught into C by 2. Mg minus Kx naught equal to Ma by 2. So Kx naught is equal to Kx naught into L by 2 is equal to, there's a rectangular plate. So I'll do one thing. Let me take this is length L and breadth B. So what is the moment of inertia? M L square B square by 12 into alpha naught. Now what are the questions that are being asked? Angular acceleration of the plate. So do we know Kx naught? Yes, Kx naught equal to mg by 2. Substitute, you'll get alpha naught. Then we'll get A naught also. But sir, what about the spring? What to do with the spring? Spring force will not change suddenly, no? Let's not bother, finish over. After some time, spring force will change as it has to change. At that moment, what happened? There's a finish over. So nothing to do with any other ideas here. So I think now string and spring comes, little bit be alert. Sudden change in spring force, not possible here. So what happened to spring? Elongated. Elongation will increase or decrease? No, it will remain as. After some time, as because of acceleration of point A, so because of the displacement of point A, things have to change after some time. We are discussing just after, immediately after. So where what is L? L is equal to C and B is equal to C by 2. I'll take the next question. And now,
The previous question, we won't get the answer 2, sir. Option 2.
Yes, sir.
this one,
Sir,
check it once.
getting, sir. 2.4 G by C.
Yeah, check calculations more. Will come. Okay, now we have did some lot of things. No, so let's go for generalization. What do you mean by generalization? Any object with the spring or this one. So I just suggest few. So please do work out. Different shaped objects are there. So first, let me give the triangular plate. Please do work out. Think on that one because now you know enough of idea. This is a string. And you know moment of inertia of the triangular plate, so that there won't be any, I think, difficulty for you. So this is length L. I'm going to cut this string. That string I'll show like this. So what will be the tension in the left string just after right string is cut? So mass of the plate be M. There's a one thing. Next I'll go for semicircular plate. Can be asked anything in advance. Huh? You have to be very careful. Mass M. I'm going to cut this string, so you have to calculate the tension in the left string here. Then semicircular plate. I'll go for cone. Later on, if you want, you can change the orientation of the string also. So initially, first you do for vertical, then after getting confidence, go for this one. There's the cone of height h, radius r, mass m. So height h, this will be. So and I'm going to cut this string. So in all the three cases, find the tension in the left string just after right string is cut. Find tension in the left string Okay, fine. So please do put effort. I think the same problem, instead of rod, square plate, I did now triangular plate, semicircular plate, and this is a 3D object. I'll go for the next concept. Now, similarly, instead of that string suddenly cut, no, now I'm going to release the rod. Read the question now. Read the question, I'll have water.